Okay, so now we're gonna do part 5, which is really, and there's really many ways to do this. And I'll just show you one of the ways you can do it. So one of the things you can do is basically use what we learned in part 4 about for loops and varying the temperature, but now apply this at another level and then do it as well with G naught, which is the initial glucose level. So if we go to our PDF, he basically wants you to vary or to explore different glucose concentrations, and then also to explore different temperatures because we want to kind of optimize it. So of course you can make it as refined or as broad as you want. So what I would start doing, so I'm not going to show you all how to do this because this part should be really you trying to design your own code, but you could definitely start with what you did with part 4. So I'm just going to copy and paste all my part 4. And then now instead of doing, so you can, instead of doing this, you can leave it the same way, or you can decide to make it a little less, like little less points. So you can make the step be 1, or if you still want to do, because at the end you're going to have a plot and it's going to have too many lines if you leave it as 0.25, but you can, like, if you the smaller the step, then the more lines you're going to have, then the more precise your answer is going to be. But if you wanted it to just be like, oh, it should be about this temperature, then you could just make the step size 1. So you can have 10, 11, 12, 13, until 20. So you can either do that or you can leave it how it was. Now, why not? It's going to be different because they're giving you initial concentrations. So first of all, we're gonna have our why not inside our loop, and I'm gonna show you why later. And we're gonna have so now we're gonna vary the glucose concentration. So now we're gonna make instead a G naught, and then we know that he wants it to be 100 or less. So then we can, same thing as we did for the temperature, we can create a G vector that has that goes from 0, or you can start at higher glucose concentration, it doesn't matter, and it can go all the way to 100. And then so if you don't have the one in the middle, it just goes in steps of 1, but you can decide what the step size is going to be. If you want it to be 5, so it's going to do glucose concentration 0, 5, 10, 20. So think about this, you're going from 0 to 100, so you probably don't want it to be too small, so you probably want it to be 5 or even 10. So you're going to try different glucose concentrations. The more you use, of course, the lower your code is going to be. So I think 10, 10, 5 is a good number. And then for this, you could do 1 or 0.5. Those are good numbers as well. We're just going to make them normal vectors now. So now your ABV is not going to be a vector anymore, and it's not going to be a vector because you're going to have, for every temperature, you're going to, so basically what we're going to do here is we're going to say, okay, temperature is 10, for example. Now we're going to vary G from 0 to 100. So for every temperature, you're going to have, for example, here we have from 0 to 10, so we have 0, then 10, 20, all the way up to 100, so you have 11 points. So you would have, for every temperature, you would have 11 glucose concentrations. So ABV is not going to be a vector anymore, it's going to be a matrix. Each column is going to be one temperature, and each row is going to be an initial glucose concentration. So in this case, it's better if you create the matrix itself. So we can create it by just basically filling it up with zeros. So we can say, okay, so let's make this matrix, just make it full of zeros, and then let's say it's going to be the length of t, and then it's going to be the length of G naught. So basically we know, so it's not going to be a square matrix because we're not going to have the same number of points, but that's fine. So basically we're telling it, okay, so make a matrix, that is going to have the number of columns as you have t's, and then the number of rows as you have g naughts. Now we're back in the for loop. So since we're looping through temperatures, but we're looping through glucose concentrations as well, you can create a new for loop inside your old for loop. How other people are doing it is just basically copying part 4, but then restarting G naught every time. So that's just going to make your code a lot bulkier. So what you can do instead is just make another for loop. These are called nested for loops. You have to give it a new variable. So this was counting variable, before it was I. Now we're going to make it J. And now you're going to make it from 1 and then all the way until the end of G naught. Basically, you're going to be looping through G naught. So then you just say, you can, oh, this shouldn't be a capital L, little L. And then we're going to make it G naught. Please don't copy and paste the code I have, because I am not paying attention, I'm not running it. So I'm not paying attention to spelling or anything like this. So if you have errors, please make sure, I'm teaching you how to do it, but I'm not being careful with how I do things much. So there might be a lot of spelling errors. Okay, so now we have the first loop through all of our temperatures, and then we have our second loop through all of our glucose concentrations. Now, same thing as we did before, we're still going to have that Arrhenius function that's going to loop through all the temperatures, and then we're going to have our ODEs, everything as before. The only thing that we don't have here, of course, it's our initial conditions, and we don't have the initial conditions because the first initial condition, which is your glucose, is varying. So you have to put the initial condition inside the for loop because it's changing every time. So please don't use the same initial conditions as before, they changed. So if you look at the PDF, then the first initial condition is changing. So we have y naught equals, and now we have g naught. And basically what that's going to do is it's going to change it every time it goes through the loop, it's going to change it. And then you have the same thing, and then you have the same thing you had before, which are just the numbers. So we have that for M, it's 220, and then for, right, okay, yeah, don't forget to put the semicolons. I don't think it matters, but and then your next one is 40, I think, and then so on. So just read part 5. It tells you what the initial values is. The only difference is that the first initial value is not a number anymore. It's a variable, and that variable is changing. So the first one is going to be 0, the second one is going to be 10, and then the third one is going to be 30, and then after it's done looping through the G's, it's going to go out and then change the temperature and then go at it again. So now we have our initial values. We have, you can indent everything a little farther so it's better, it's easier to understand. Now we have our first loop. Don't forget to put the end of your second loop. And so the only thing that we're missing here is that now ABV, as I told you before, is a matrix. So now it has to be I and then J. Basically what we're doing is we're filling up the first column first. So we're going to say, okay, so I is equal to 1. So it's going to give it a temperature of 10 degrees. G naught is going to be equal to 0 at first, right? And then it's going to calculate all of your Arrhenius constants for that T, which is the initial one is 10. Then it's going to do the ODE. And then we're going to give it, so this one's going to correspond to the first one. For example, if I equals 1 and J equals 1, the first ABV is going to be 1,1, which is going to correspond to a temperature of 10 and an initial concentration of glucose of 0. And then that's it. The same thing. This is the same thing as you did for your part 2. Again, don't copy what I'm doing. Like, I didn't add all the sig figs and I didn't add the 10 to the -5 part either. So this is just an example. And then you can go ahead and plot it. So after your loops, what you can do is you can say, okay, now plot it, and you can plot it as a contour, because now we have two things that are changing. So the same thing as we did for part 2, you can just plot as contour. This time it's not going to be f contour because you're not plotting a function, you're actually just plotting vector. So you can just say contour, And then you can say, well, your temperatures, and then your G naughts, and then your ABVs, um, and then your ranges. So what goes in the range is you want to plot basically what gets close to what the percentage you want. So you would have many in between here. However, the best thing to do is, okay, we want to know what 0.05 or what 0.5 is, which, or the percentages. I forget what the percentages are. They're 5%, I think. Okay, so it'd be 5, and then you'd be, what's the next one? It'd be 6 and 7. And then that's it. Then you can just add your X labels, which of course is going to be temperature, and then your Y label, which is of course is going to be your initial glucose concentration. And then you can just analyze the graph and then write a little note on, like, okay, so based on the graph and based on my calculations, I calculate that the best conditions for 5, 6, and 10% are these and this and this. And then that's it. And you should get all that information more or less from your graph. So you're not going to need specific values. Like you don't need to find exactly what T and exactly what G need to be for exactly hitting 5, 6, and 7%. It's a rough approximation that you get from your graph. And that's all you have to do for part 5. I hope this video was helpful. Feel free to post questions on Piazza so that everyone can see your questions and then your answers, and then some of your classmates may be able to help you.